We'll proceed in parameterization of surface. Later we'll see volume, Jacobian. Every time we see a new thing in calculus, then we say this is the most complete thing we have seen in the calculus. Step by step, we started with anyone would start with the numerical signs. 2 plus 2, 2 plus 2 plus 2 equal to 2 into 3. 2 into 3, 2, 3 times. Now, if this is numerical science, then further it promoted to algebraic science. Now, if it is algebraic science where things are variable, now if it is algebraic science, then calculation of multiplication through algebra and we came to integration. Entry into calculus, that is integration, calculation of multiplication through calculation of area of algebraic graph. If I have x-axis, y-axis is dependent upon x-axis. This is the terminology that calculus brought in. And then we have independent component, dependent component. Dependent component graph can be drawn with respect to independent component. Whatever the limit, whatever the interval I want, in that interval, if I want to calculate the area, then integration of this graph along the independent component gives the area. Now, on top of it, now this is Cartesian coordinate system x and y. On top of it, people started thinking polar coordinate system, cylindrical coordinate system, spherical coordinate system, because things were easy in those coordinate system. Those are Cartesian only. If I have x axis, and then if I have x axis and then there is some radius that is moving in a angular fashion. If this is x axis, there is a radius and it is rotating in angular fashion. So any two moment, it gives one arc, one angular region. So this angular region, if that is the region in Cartesian coordinate, then people started thinking about polar coordinate system. In polar coordinate system, theta or plane is nothing but Cartesian only. Their rectangle maps to circular region in xy plane through a mapping function that is called parameterization. So, numerical science to algebra. Algebra, when used through calculus, independent, dependent component. Now, when it is used as independent and dependent component, it comes into picture of coordinate system, and there we have different coordinate system. Now, based upon the algebra, not based upon the calculus, based upon the algebra, there is a new terminology came as a vector field. Algebraic vector, a vector which has different components, each component is now algebra rather than numerical 2i plus 3j rather than x plus yi plus x plus sine yj. So this way the calculus is growing. I mean the mathematics is growing in this fashion. Now question arises is when we started talking about commercial calculus and then we came to curl. Curl means a vector field integration along a particular line, not along the x-axis, not required, along any axis, and it was called as line integral. If I do the integration of a vector field, algebraic vector, along a particular surface, not along xy plane, not necessarily always integration along xy plane, along a particular surface, then it was called surface integral. If I calculate differentiation along x-axis, that is the default one, but I am free to do derivative, calculate the derivative of an algebraic equation along any vector. directional derivative along a vector. So many things we saw. And we kept thinking that these are the most advanced thing. Lagrange fundamentals in maximization, minimization theory that we saw. Everywhere we have our own idea, own proof, because we feel that whatever the analogy, description that is provided in book, that is confusing, and that is just because to reach the solution. If you have problem, you know the solution, how to reach problem to solution, people have done whatever it came to their mind. And this is how people started getting deviated from mathematics, because it is too difficult. It is not too difficult. Wrong way people are describing the mathematics. Everywhere we are bringing the correct way, like maximization, minimization, Lagrange way. Lagrange principle, if you see, it is highly complex. Just do the directional derivative along a vector, immediately you can get maximum minimization. No need to go for high class fundamental. So many things we have brought in. Now, now calculus has come to a stage where there is, we know area vector, calculating the area vector. If I have xy plane, we are saying that always consider only one independent component. If it is x-axis, y-axis, then y is dependent upon x-axis. If it is z-axis, that is dependent upon x and y, no. Z-axis fxy is dependent upon xy plane, not on x-axis and y-axis. Consider xy plane as single independent component. More research are required while considering a plane as independent component, not an axis. XY plane is single independent component, not an axis. If that is the concept, if this is XY plane, means x-axis, y-axis, XY plane, where origin is there on the XY plane. If this is fxy, if this is z, function over xy, then there is a surface on top of xy plane. If this is xy plane, there is a surface on top of xy plane. If I take any point on the surface, this point can be represented as x, y, z. X, y, that is a point on xy plane, and z is nothing but function over x, y only. X, y, f, x, y. Any point. If that point is a position vector, then dp by dx cross dp by dy, it gives the area change in area vector. This is the maximum someone would get in the book. Maximum. That is also not very clearly available in all of the book. People go for delta approximation. If it is a rectangle, it is parallelogram considered is very small, infinitesimally small, then rectangle become a parallelogram, then now people start deviating. How I can consider if rectangle is very small, then its functioned conversion would become a parallelogram. How I can consider? But why don't you take the power of algebra? Do calculus on top of algebra. What about the variation what we see? That is limited on algebra. Calculus is also based upon the layered signs only. If you see the hardware, electronic circuit hardware, if you know a particular, how transistor is made. Transistor is made because there is a diode and it works perfectly. If there is a diode and people know that it works the way they think, or they know how it works, it is causal. Causal in a sense, it is predictive now. Then based upon it, transistor was made layer by layer. How diode was made? Because people were sure about the resistance functionality. That if there is a resistance, if you apply voltage across it, certainly current would flow. If current is flowing through a resistance, then it will develop a voltage across it. Now people are sure about resistance. So on top of resistance, variable resistance, that is diode. Diode is nothing but it's a variable resistance based upon the voltage. it changes its resistance somehow. Then resistance, static resistance, variable resistance. On based upon variable resistance, then transistor came dual variable resistance. So if I have a two diode, I'm not talking about two different diode and connect it through wire. If I have dual junction diode, diode is single junction. Dual junction diode, if I dope it in a fashion, in some peculiar fashion, then one junction, if I make it forward bias, minimum resistance or zero resistance, another junction I manage to make it reverse bias, then it starts behaving like a switch. Dual variable resistance can give very peculiar result, step by step. On top of register, now when they saw that it is very nice, they can do it, then field effect transistor came into the picture, more into the switching. Okay, quickly it will switch field effect transistor. Then integrated circuit started coming based upon the field effect transistor, step by step. Mathematics can be under. Now if I am talking about transistor, and somewhere, and then I am giving formula, but everything is based upon the diode, because transistor is based upon the diode. So whatever the transistor can provide extra, like switching functionality and those things, that it would provide. But underneath, the basic functionality is from diode only. Diode, whatever the variation it can provide, it would provide, but basic functionality is of resistance only. Similarly, if I go in calculus and if I do the calculation, calculus means calculation, if I do, then whatever the calculus can provide extra, that it can provide. Otherwise, basic functionality is provided through algebra only. And algebra is nothing but variable. Rather than writing 2 plus 2 into 3, write 2 into x, where x would change and then the multiplication would change. Similarly, if I calculating dp by dx, now we were in discussion for dp by dx. dp by dx cross dp by dy. If I have xy plane, if I have a surface, and I take any point P here, xi plus yj plus function over x comma yk zk, then dp by dx cross dp by dy. dp by dx is, if you see here only, it is I plus dz by dxj. dp by dy is j plus dz by dyk. dp by dx is in xz plane. dp by dy is in yz plane. If there are two vectors in yz plane and in xz plane, if you do cross product, it will give you the area in between. Now, how the area will be? If this is the surface, here the area vector would go like this. Here area vector would go like this. Here area vector would go like this. Why it is like this? Why it is not in one direction? Because what is the algebra at this point? Leave it on algebra. Why you are going for infinitesimally small here and there? Leave it on algebra. So algebra, whatever the algebra is doing, if I am calculating area vector here, that is dp by dx, dp by dx is I, that is fixed, plus dz by dx is completely algebraic, k. That is the factor that gives me the xz vector, yz vector, full algebra. And at that moment, whatever the I and k factor, that is dp by dx, whatever j and k factor as per the algebra, dz dp by dy, that is the direction of the area vector. Everywhere area vector direction would change depending upon the algebraic fundamental at that point. So variation, when we see in calculus, it is completely handled by the algebra. Calculus integration especially, it only talk about the multiplication, calculus through calculation of area. If you want multiplication, you go with integral calculus. If you want division, you go with differential calculus. That's it. Algebraic division is differentiation. Algebraic multiplication is integration. That's it. So that is the concept. So dp by dx cross dp by dy, whatever what it is, dA by dxy, change in area by change in xy plane. What it is, what it is. So it is like if I if this is xy plane, if this is xy plane and this is the surface on top of it, then if I draw a rectangle on xy plane, if I draw a rectangle on xy plane, that rectangle would map into some region on the surface. This region is, can you see, it's not flat, curve. So that region would map some area. It may not be parallelogram, it may not be rectangle, it may not be circle, whatever the fxy is, function over x and y, that is z, whatever the formula is, based upon that rectangular region in xy plane would map into some surface region in fxy, z. If there is a dp by dx cross dp by dy, if that vector calculates the area, this is d area by dxy. Dxy means if there is a rectangle in xy, these explanations are not available anywhere else. You go and search any best book you can see in calculus. Please support us. Our telephone number is +91, that is India country code 94831 60610. 94831 60610. +91 is India country code. Anyway, so this helps. Anyway, now support motivates everyone. Anyway, now if if I have a rectangle, if I have a rectangle on xy plane and this rectangle is mapped on surface, then dp by dx cross dp by dy is the area on surface by dxy plane. If there is a unit change in this rectangle, if this rectangle has area called alpha meter square, if there this area becomes alpha plus 1 meter square or alpha some unit square, it may not be meter, it be maybe millimeter square, whatever it, alpha some unit square. If there is one unit change in this area, how much unit change of area it brings on the surface, mapped surface? If there is a rectangle, if there is a rectangle on xy plane, on this rectangle area is alpha any unit square. If I add one unit there or subtract one unit there, that is one unit of change. If I make one unit of change, if this rectangle, the original rectangle alpha, is mapped on the surface area, if there is a one unit change in this alpha area, how many unit of change that happens on the surface? That is calculated by dp by dx cross dp by dy. Typically it comes as minus dz by dxi minus dz by dxi minus dz by dyj plus k. This is the rate of change of area vector. This is rate of change of area vector. The net would be then its magnitude, dz by dx whole square plus dz by dy whole square plus 1 square root. That is the change. So that amount would change if there is one unit of change that is seen in the rectangle that is on xy plane for which it is mapped on the surface. So this is d area by dxy plane. This is the most latest calculus because it involves vector, it involves Cartesian coordinate system, it involves calculus, it involves algebra. What is bigger to it? Bigger to it is change in coordinate system. Consider, consider this is UV plane. Rather than XY plane, this is UV plane. Now the x-axis is now u and y-axis is v. This is UV plane. If I draw a rectangle on UV plane, this plane maps to one region surface that is XY plane. That is XY plane. So if there is a rectangle, then it may map to a circle on xy plane. How a rectangle in UV plane can map on xy plane as a circle? Can you explain? Yes, I can explain. when x equal to u cos theta and y equal to u sin theta. Because if this is xy plane is mapped on uv plane, there is a function that is associating uv plane to xy plane. If that is the case, then x equal to the function is f equal to guv, y equal to huv, x equal to guv, that is r cos theta, y equal to, sorry, u cos u, that is v cos u, and y equal to v sin u. So UV plane is now mapped into XY through this fundamental. Now UV plane, I have a rectangle, then mapped one will be a circle. Certainly the way equation is x equal to v cos u and y equal to v sin u. If there is a rectangle in UV plane, and if that associated to xy plane through this formula, then there will be a circle in xy plane. If there is a unit change in this rectangle, then how many unit change it is bringing in the circular area? That is dxy area by duv plane. That is, if I take any point P here, then the position vector of this P, if it is mapped from UV plane, then the position vector of this P will be G UVI plus H UVJ. That is the position vector. It is also called parametric vector. R vector above it arrow mark u comma v equal to g u comma v I plus h u comma v, or position vector is xi plus yj, whatever is feasible. Now what is this? What is the change in the area in xy plane with the unit change of area in uv plane? If there is a rectangle on uv plane, then dp by du cross dp by dv, that is called change in area in xy plane, xy coordinate system with the change in uv coordinate system. Change in one unit of area in rectangular region on, this is better word, on uv plane brings how many unit of area change in the mapped area region in xy plane. dp by du cross dp by dv. This is called Jacobian. This is the most advanced whatever we have seen till now. Not only we are calculating the area vector, we are seeing change in area with the change in a rectangular region in another coordinate system. Change in the area in one coordinate system with respect to change in the area in another coordinate system. These two coordinate systems are associated through function that is called parameterization. X equal to g is the name of function, x equal to guv. G is a function, uv is parameter, this is called parameterization. Y equal to huv, parameterization. In xy plane itself, if there is a z equal to fxy, that is also indirective parameterization only. Okay, this much advancement we make. What is next? Next is that we will go for volume parameterization. This is area parameterization, volume parameterization, three dimensional, n dimensional. If there is an n dimensional change in UV plane, how much n dimensional change it will bring in XY plane? But anyway, before going that far, we will do one more example, and we will do tons of example. We are not going to run away. So more example we do, more clear it will be. So now consider that I have a circular region in Cartesian coordinate system. So circular region in Cartesian coordinate system, okay, I don't know, one my vector is missing. I'll use this as a vector. Okay, so this is x-axis and this is x-axis, better, and this is y-axis. This is x-axis and this is y-axis, and this is the origin. Now I have a circle that is centered at the origin. I have a circle that is centered at the origin. Now you can see there are four quadrants. One quadrant where x and y both greater than 0. So we are talking about this quadrant, second quadrant, third quadrant, fourth quadrant. This quadrant x is more than 0, y is more than 0, x is less than 0, y is more than 0. Here x and y both less than 0, and here y is less than 0 and x is more than 0, positive. Fourth quadrant. We are talking about the first quadrant. X and y both are more than 0. Now what about this region? This first quadrant is a region where x is 0 to 1. Means the circle has radius as 1. 0, x is 0 to 1. Y is 0 to square root of 1 minus x square. Now there is a integration over a region. X is 0 to 1. Y is 0 to square root of 1 minus x square, and the z, if this is xy plane, then there is a region that is first quadrant of the circle somewhere here. On top of that region there is a surface. Equation is x square plus y square. So integration over the region, that region is 0 to 1 on x, and y is 0 to square root of 1 minus x square, and the function z fxy is x square plus y square dx dy. What are we trying to do? We are trying to calculate volume of a surface, where surface is mapping on xy plane in a region that is first quadrant of a circle. If I take a region on xy plane as a circle, if this is a region on xy plane as a circle, it has four quadrants. We are talking about the first, this is first quadrant from my side, this is second quadrant, third quadrant and fourth quadrant. Only first quadrant, whatever area someone is seeing, that area, if we go up and it maps in the surface, okay, that region on the surface, if it comes down, what is the volume? Integration of a surface along xy plane gives the volume under the surface, where xy is confined to a region that is the first quadrant of a unit radius circle. Now if that is the case, then what it is? Okay, x square plus y square dxy plane and integration over the region. Now it is very difficult. X square plus y square, and then calculating, if I calculate the integration with dy, then it is x square y plus y to the power 3 by 3, and then now substitute against y as square root of 1 minus x square. X square into a square 1 minus x square root plus 1 minus x square to the power 3 by 2 divided by 3. Now integrate with x, anyone would start sweating 100%. In the winter season also, he would start sweating. So integrating along xy plane is difficult. So integrating along xy plane is nothing but dxy is same as dxy by d theta r into d theta r. So d theta r is theta r plane, that is d theta into dr. Dxy by d theta r is nothing but if there is a position vector on xy, dp by d theta cross dp by dr. Okay, so if that position vector is xi plus yj, then dx by d theta i plus dy by d theta j cross product with dx by dri plus dy by drj. If you do cross product, it becomes dxy by d theta, that is Jacobian. That you calculate, d theta dr is anywhere there, and now substitute with the function. This is how we proceed in the most complex region in the calculus. So now whatever the parameterization someone is taking, x, y and theta are plane relationship, that need to be substituted in the integrand, and then limit would be changed. This much someone has to do when he is doing the delegation of xy plane work into theta r plane. If that is the case, then if I consider that x equal to r cos theta and y equal to r sin theta, then x square plus y square is r square. And now Jacobian someone calculate where y equal to r sin theta, x equal to r cos theta, then dx by d theta I plus dx dy by d theta j cross with dx by dri plus dy by drj. If these are the determinant of a matrix, then the cross product would lead into r. So r square r to the power 3 dr d theta, that is r to the power 4 by 4 dr d r to the power 4 by 4 limit 0 to a square root of 1 minus x square. Now it is in Cartesian still. That limit I need to change. So y equal to a square root of 1 minus x square plus y square equal to 1. X square is r square cos square theta, y square is r square sin square theta. So r square equal to 1, r is 1. So it is, and y equal to, we are changing y equal to r sin theta. 0 is y, then r would be 0 only, because r would be 0 by sin theta, r would be 0 only. So 0 to 1 is the limit for the y now. So let's replace it. So it is r to the power 4 by 4. It is now 1 by 4. 1 by 4 I can keep outside and simply integration of d theta. That is theta. And theta would go from where to where. If I am taking one quadrant, then it should go 0 to pi by 2. But fundamental are fundamental. Mathematics is not based upon approximation. You have to give concrete proof. So x is 0 to 1 as per the quadrant. X is 0 to 1. X equal to r cos theta. Y equal to r sin theta. Y by x equal to tan theta. Theta equal to tan inverse of y by x. If y equal to 0, sorry, tan theta, y by x equal to theta equal to tan inverse y by x. Y is the square root of 1 minus x square. Tan inverse square root of 1 minus x square by x. If x is 0, denominator is 0, then tan inverse would be 90, pi by 2. Pi by 2, 2, where x is 1. If x is 1, then 1 minus x square will become there. Numerator is 0. If numerator is 0, then tan inverse 0 is 0. Okay, so it is pi by 2 to 0. That is better answer, pi by 2 to 0. Okay, so now it is d theta. Theta is pi by 2 to 0 minus pi by 2. That would be better answer. Minus pi by 2. So pi by 2 into 1 by 4. That is the net into minus pi by 8. That would be the better integration. We will proceed. We are not running away. We will talk about 3D Jacobian and then more in the integration. More and more we do, more clear it would be. So when you are trying to do everything in calculus, d area in one plane to d area in another coordinate system, and then you have kind of vector field, calculus, algebra, everything together change in coordinate system, you are landing up into parameterization with Jacobian. So we will do more example. We are not running away. That we will see.